Okay, in this video, we will discuss about the reverse display. Last time we saw how we can add the record in the W linked list and how display works. Then let's go and try to traverse the reverse display. Okay, like if we have to traverse in the opposite direction, then how we can do that. So for that, let's go and let's trace the code. So here we will go inside this, we'll say F11 control came here, and then in reverse display here what we are doing, we are just creating the temp, the one we are creating this reference variable in the method. So this temp will be the local variable, and in this whatever the address we have inside the head, that will be assigned. Okay, so we can say temp, we can say one reference variable temp, and inside that whatever the value we have inside the head, that is 2000. See, it is not, there is no way that we can directly jump to a particular element or node in the linked list, because unlike array where we have the index and you just need to give the index and you will be able to directly fetch the value present at that index. Unlike the array, we need to traverse in order to go at particular index or any node, I can say, in linked list. So here, in order to traverse in the reverse direction, first we have to go onto the D node. Okay, so first let's try to go on the D node, and then we will start traversing in the reverse direction. Means we want to print the data in reverse order, first 19, then 34, and then 7. So this basically will be doing. Okay, and for that, here we have one object no temp, inside that we have the value inside the head, that is 2000. So diagrammatically again temp will be pointing to b object. Okay, and then temp is equal to null. If you see, temp has some address, it is not null, so this condition became false. This condition we have written, if the linked list would be empty, then it will be null, and then we could give the message linked list is empty, but currently it is not, so it will skip that one. And then here we have written the logic, and this logic is just in the just like a iteration, where our intention is that first we should reach to D object. There is no way, as I already mentioned, to jump directly to the D object. We can't directly go. So just by traversing only we can go. We need to go first by B object, then C object, and then D object. And from D object we will start printing the value. Okay. So here if you see this one, temp dot next is not equal to null. Of course, because temp is pointing to B object. So next of B object has some address. 3000 is the address, which is of course not null. Okay, condition became true, it will come inside that. Then whatever the next of temp, or I can say b, next of b object will assign to temp, that is, next of b object has 3000. So again this expression will be evaluated to 3000, and this 3000 we are assigning to temp. Okay, so the new value of a temp will be 3000. Currently I am not drawing the arrow, just to save the time. Okay, otherwise I believe you will be able to guess कि at this point of time temp will be pointing to C object, because temp is holding the address of C object. Okay, then again control will go to here, and then temp dot next. So temp is pointing to C object, and next of C object is having 4000. Okay, so here this is the 4000, or you can say non null value, it is definitely some value. Okay, so other than null, so it is not equal to null, condition became true. Control will come to this while, and here if you see temp dot next means next reference variable, which is being pointed by the temp. Currently temp is pointing to C object, so next of C object have address 4000. So this 4000 basically, this one will be evaluated to 4000 currently in our example, and this 4000 will be assigned to temp. Okay, so this one now this 3000 will be overridden to 4000. Okay, so here is the 4000. Okay, and now you will be able to guess that this temp have started pointing towards the D object, because temp is holding the address of D object, right? Means this temp has reached to D. This is what we had the last object, and then now it will go and temp dot next again. Temp is currently pointing to D object, so next of D object is not null. If you see, so here the next of D object is null, right? So this expression will be evaluated to null. Null is not equal to null. Condition became false. Control will come out of this while. So basically, I told you in beginning only, like this while block was written just for the purpose was like we should reach out to the last element, and now temp is having the address of D object, that is D object, which is the last object. Now from here we are in a position to go in the reverse direction. So let's do that, and now check. While temp is not equal to null, do you think temp is equal to null? No, temp is having the address of D object, right? Definitely it is not null. So this condition became true. Hence control will come inside the while. It will print the data temp dot data. Question is temp is pointing to which object? Temp is pointing to D object, right? Because in temp address is 4000. So in the object there is a data that is 19, right? So it will print 19. If I hover my mouse, you see it is printing 19, then a space will be printed and it will come out. Then here what we are doing, we are saying a temp dot previous. If you remember the last execution, there we were assigning the value of next, but no, this time we have to travel in reverse direction, right? So we have to read the previous because we want to go in reverse direction, and we know this object has previous reference variable which is holding the address of previous object, right? So previous is having 3000. Okay, so that 3000 temp dot previous means previous of temp object. Temp is currently pointing to D object, so previous variable of D object is having the address 3000. So that 3000 will be assigned to temp, right? So this 4000 will be overridden, and the new value of the temp will be 3000. Okay, and means now I can draw diagram just to reduce the simplicity, just to make the thing simpler. So temp has started pointing to C object now, right? And then it will again execute the while. So temp is not equal to null. Yes, because a temp has some address. Definitely it is not null. Condition became true. It will go inside, and then we are trying to read the data. Which data? The object whose basically I can say the object which is being pointed by the temp reference variable. So currently temp is pointing to C object, means data of C object is nothing but 34. If I hover my mouse in here, you can see the value we are getting is 34, right? So it will print 34, it will come here, and now you see the value has been started printing 19, then 34. Okay, and then again, since we want to go in the backward direction, so temp dot previous, temp is pointing to C object, and previous of C object having address 2000. So this expression evaluated to 2000, and this 2000 will assign to temp. Okay, so this temp will have the new value, that is 2000, and then it will start pointing to B object, because we know now the address which is present inside the temp reference variable is of object B. So we can say it is pointing towards the B object. Then it will again go for the while block. It will check whether temp is not equal to null. Yes, temp is still pointing to B object. It is not null. Condition became true. It will come inside here. It will read the value of data. That is data of which object? Temp object or B object, because temp is currently pointing to the B object, right? So the value is 7, and here in our example also it is 7, right? So this way it will print that value, and then temp dot previous. Okay, my control disappeared, but let's continue this execution. So temp dot previous means this time if you see, the first element is having null. Temp dot previous means the previous of the temp object, or the object which is pointed by temp is pointing to B object, so previous of B have null, so this evaluated to null assigned to temp. Control will again go to here. This time temp will be null. So null is not equal to null. Condition will be false. Control will skip this while block. It will come here, and here it will change the line. Okay. So this is what basically it was in middle only. Let me execute once more just to cross check that we are getting all the values. This time I will put the breakpoint here, and let's run this and check whether we are getting the output in reverse order or not. You see 19, 34 and 7. So this is what we, if we want to traverse in reverse direction, this happens in doubly linked list. Since in singly linked list we doesn't store the address of previous node, hence we can't achieve this one in singly linked list, but in easy manner we can achieve it in doubly linked list. So this is the reverse traversal, right? This is the straightforward or one directional traversal, and this is the reverse traversal. Then we have one more method, like here delete node at a specified position with -1. So what it does, it will check. So logic that we have written here is okay. So let's go and try to understand this. So in here, the position became -1. We are checking position should be greater than equal to 0. Since it was -1, hence this condition will be false. It will jump to else block, and in else block, it will print this message. Please enter positive position number, where 0 would be the position of first element in linked list. That message we can expect here. If I run it again, you can see we are getting that message, right? So this is what we are doing. If we go and check, like see out of this 7, 34 and 2 19, we want to delete 34. Okay, so how we can do? So for us, we have assumed the first position is 0, so 7 will have 0 position, 34 will have the 1 position. So let's see कि we want to delete the element at first position, that is nothing but 34. Okay, so this we want to delete. Let's execute this code in debug mode and check how it will work. So simply we will run this. Let's go. Position is 1. Okay. And then here the control is again it will check, because position should be either equal to 0 or positive. It should not be negative. That's why we printed this message. Please enter positive number. Okay, then position is greater than equal to 0. Condition will be definitely true because position is 1. Then here if head is equal to null, if you see currently head is not null, right? So if it is not null, condition will be true. Okay. Here this one is not null, means for us head has some value, it is not null. So this condition will be false. Head is not null currently. Head is holding some address, right? It is having some address of object. So it is not null. So this one will be escaped. And as usual, this condition we have been writing just to ensure whether linked list is empty or not. Then again, in order to traverse, so that we can go at that that specific position, we have created a temporary reference variable, and inside that, whatever the value present in the head, same address we are assigning into temp also. So one reference variable temp will be created. Okay, last time this would have deleted. Let me delete this because it was created locally. Yep. And here I can say one again, this time temp will be created. So temp equal to 2000. Why? Because whatever we have in the head, currently we have 2000 in our example. So that 2000 will store to temp. That this is what basically we are doing here. When this line will execute, then we are checking if position is equal to 0. If position will be 0, it means we want the first element to be deleted, but not position is 1. So this one will escape and control will come here. Then for int I equal to 0, just for a traversal purpose we have applied this for loop. Then temp is not equal to null. Of course temp is not null, it is 2000, means I can say temp is having the address of b object. Okay, so this is true, and I is less than position. I is what? I is 0 currently because we have initiated with 0. So position is 1. This condition also became true. So entire condition became true. No, this entire condition doesn't become true. The reason is temp is not equal to null. This condition is true, but this one is false. The reason is position is 1, 1 minus 1 became 0, and I is already 0. So 0 is less than 0. No, this condition became false. Hence, this is the AND operator, means entire expression will be false. It will not go into the for loop, it will escape that one. Okay, and you know it came to here. Now we are saying कि if temp is equal to null, no, temp is still not null. Temp is pointing to b object, right? So it this condition also became false. It will check temp dot take next is null. Temp is pointing to b object, so next of b object is null. No, this is also false. So both are false. Control will jump to next element, and here it will try to delete. So let's watch it precisely, guys. Otherwise, chances are more that you will get confused here how it will work. So basically, temp dot next. Okay, this we know very well. This is something that we have been learning from the very first minute when we started the video. Temp dot next means next variable in the object which is pointed by temp. So temp currently is pointing to b object. So this means this next is of which object? B object, right? So next of b object. So till here we evaluated next of b object, and next of b object having 3000. Okay, so this expression evaluated to 3000, or you can say 3000 is the address of c object. Okay, so till here we can assume we have the address of c object. Okay, and now this next is of which object now? So this next is pointing to C object. So this is the next of C object, right? So next of C object is nothing but 4000. So this entire expression evaluated to 4000. I repeat, temp dot next is nothing but next of b object, because temp is currently pointing to b object. So next of b object having address 3000, right? So this one will be evaluated to 3000, and we know 3000 is the address of c object. So in c object we have next variable, and inside that the value we have is 4000, right? So this entire expression evaluated to 4000, and this 4000 we are assigning to next local reference variable. Okay, we are creating one local variable. How will you get to know this is a local reference variable? It is inside the method. And how we know this is a variable we are creating? So name of the variable along with data type is called variable creation. Okay, so one reference variable next will be created here. I can say next, and inside that address will be 4000 because this expression was evaluated to 4000, and this 4000 we are assigning to this next, right? So this next now will have the address of 4000, or I can say this next will be pointing to D object because 4000 is the address of D object, right? Then it will go to next, and then what we are doing, whatever the address present inside the next, that is nothing but 4000. That 4000 we are assigning to next of temp. So next of temp, or you can say temp is currently pointing to B object, right? This is the temp and it is holding the address of B object. So temp dot next means next of B object. So next of B object we are assigning the value to this next. Which next? This none. 4000, right? So this next of B object will have 4000. Okay, so this 3000 will be overridden and the new value will be 4000. And I believe you might have understood that this next have will be stopped pointing towards the C object. So this arrow became false now, and then basically this one will start pointing to this next D object, I will say, right? So this next is holding the address of D object. Okay, then if you see now in C sharp there is a concept of garbage collection. I will explain in some time. So that's it, we are done. And now this is the change we have done. So question is, where did we delete? Basically what happens, guys, if you see now there is no reference variable available for C object, means there is no reference variable which is pointing to C object. So far next was pointing to C object, but now this next of B object stopped pointing towards the C. So there is no reference variable which is pointing to the C object. So this C object will start behaving like orphan object. Okay, and this one will be automatically garbage collected. We don't have to delete. Garbage collector will come, garbage collector will find there is no reference variable available for this C object, and hence this one will be wiped out. So this one will be deleted automatically. Okay, now next is pointing to the D object. Okay, and this way the deletion would be done, but still one more changes are required, and that changes is this previous should not point to C, rather this previous should pointing to the one whose address is temp, I can say. Okay, so now we can say next dot previous. So here we need to write the logic. I will write here. We have modified the next, but we are not taking care of previous. If you see currently, this previous is still pointing to C object only, which is now, since this C will be removed, it doesn't make sense that still it should point to C. Now this previous should be pointing to this next, right? And this has address 2000, same address present inside the temp. So how we can write? We can write next dot previous. So next of this object is pointing to D, or we can also say this next is also pointing to D object also only, right? So next dot previous means previous of D object. Here we just need to write next dot previous. So next dot previous equal to what? So guys, in this previous, what address we want? We want the address of previous object. Since this got deleted, we want the address of B, and that address is present inside the temp. So we can simply write here temp. Okay, and we are done, right? So next dot previous will have the address of temp. This way it will be holding the address of now. So when it will be done, temp is having 2000. So here this 2000 will assign to previous of which one? Next vary an object which is pointed by next. Next is pointing to D. So previous of D will have temp, that is nothing but 2000. So this 3000 will be overridden by 2000. Okay, so this previous will start pointing to, I can say, this B object, something like this. Okay, and then we have successfully deleted. Okay, simply here if we say go and now print the value, so this display will just display the value. So if you see now 7 and 19 are there. Okay, but 34, this is this is for reverse direction, and this is the normal flow. So you see we gave the position, right? In here we gave the position 1, means we wanted to delete 34, and if you see in our output that 34 has been deleted. This is our new linked list where we have 7 and 19, and in between them 34 has been deleted. So likewise this logic you can use to delete for the element from any specific position. Just pass the position and then you can use this method to delete. I believe you have understood it. So this is what basically we have for this one, guys. And yes, even the same logic will work for singly linked list also. Like if you want to delete the element at a specified position in a singly linked list, so there also it will work. The same logic will be working for singly linked list also. That's it. Thank you.